video is going to be about me. I made a promise to myself I wouldn't buy cheap stuff to try to do work with, because most of the time that ends up not being the least costly way to do things. At least in the machine shop, it usually ends up being that way. And this is a good example. This thing right here in my last video, I bought this and it was inexpensive, and I thought, you know, is this going to work out? And I took all the time to machine the ID to fit the part, but then the thing fails. And I should have just done it the right way to begin with. So this video is going to be about remaking this driving dog. And I do it in a way that I don't really recommend doing it. You know, there's better ways to do this, but I thought it might make an interesting video. So watch the video and see what you think. Here's the way the day started. I thought I was going to be turning these things down, and just spending all day turning these things down. So about, I think, the third part, I turned the third part, and then when I took it out of off the centers, and I put the lathe dog on and tightened it up, the thing broke. You'll hear it in the video. I just had this little sequence of turning the OD of these parts. This isn't really a critical turning operation. It's just to rough off some of the stock. I don't know why they bought stock that was so big in diameter. The part finishes to 2.807 and the stock is 3.25 in diameter. So, but I want to tighten that lathe dog pretty tight, because I'm taking, you know, pretty aggressive cuts, roughing it down. Now if you listen carefully here when I tighten this thing up, you'll hear it break right there. So I said, what? And I back it off and look, and the thing split in half. See where it broke? And this thing was supposed to be cast steel according to the catalog, and I would have returned it, except that I had machined the ID, and then you know, you can't return something you machine on. So I scoped out these pieces of aluminum. I thought, I'll make one out of aluminum, and I'll put a bolt in there to catch the jaw, and that's a way to go. But I thought, wait, this might give me an excuse to go forge something over at my storage. I have this forging stuff. So I decided I'd try forging it. So I drew that little model in the computer, give me an idea of what I was doing. I started with 1.25 inch. I think this is A36 steel. It's just plain mild steel. I forged it out with the power hammer here, roughing it out. I'm by no means an expert or even real knowledgeable about doing this stuff. I just play with this as a hobby. But I thought, you know, it's kind of a challenge. I thought, you know, if I could make this part and make it function for what I want to do. Like I said earlier in the video, I don't recommend doing it this way. I could have probably machined one faster out of that aluminum, but I thought this would be kind of interesting to do. And I did kind of want it out of steel so it wouldn't break or anything, because I was tightening it pretty tight for those roughing cuts I'm making with the roughing tool. If I had just been doing a skim cut on the OD, that cast iron thing might have worked fine. So here I'm measuring for this tenon. I'm going to make a tenon on the end for the rivet joint. I need to butcher it in here to start with. I'll try to establish reasonably square corners where the tenon's going to end. This is just a little tool I made a while back to do this kind of thing on the anvil. So then I changed the dies. I have different dies that go in this thing, so I can do different size round tenons and various things like that. So here I changed them to the round, half-inch round. This is a half-inch diameter tenon, and it kind of smooths it out. So now I'm going to mark for the where I want the hole for the tenon to go in with a center punch, so I can see it when the material's all scaly and red hot. And also I want to bend the bend here, which is what I'm doing now on the vise. and refining that shape a little bit here. And checking the dimension. I'm going to punch the hole through. Except for grinding on this thing and using the power hammer, I didn't use any machine tools at all to make this. It was all forged by hand, except for the power hammer, of course. So I'm getting a start hole through here, punching it, this punch. The reason I'm using that Home Depot bucket with water in it is my other one rusted through and the water all leaked out. So I don't recommend using a plastic bucket for this kind of thing, because that hot metal will melt right through it if you're quenching stuff in that plastic bucket. So here's the back side. I'm driving the punch. You can see the mark that if you drive the punch down to the anvil's face, as far as it'll go for the first side, you can see the mark on the back side. It's kind of got a cooled off area, and you can see it where to punch from the back side. And I'm opening it up so that a 1/2-inch rod will fit through it. And here I'm just checking, you know, I cut the stock a little bit long, so I had to cut off this end here, and it left a little bit of flashing or burr on there. I had to grind it off. Here I'm just roughing out the shape of to go around this. I had a piece of 3 1/4-inch rod that happened to be about 15 thousandths bigger in diameter than the parts were, so it would make an ideal gauge kind of a thing to gauge this and to forge around. And here I'm just riveting over the rivet. Having difficulty with it clamping in the vise tight enough to keep hammering it down. So I end up opening the jaws up of the vise and sort of hammer against the vise. Not the best way to do it, but I didn't have any other way at this moment. And I was trying to get this thing done in a hurry. So that's that piece of 3 1/4-inch rod that's a little bit bigger than the part's diameter, so if it fits over that, I know it'll fit the part. And you bend the ear a little bit so it's sort of parallel to the bore. It doesn't have to be perfect. It just has to engage the chuck jaw on the chuck. I'm just trying to refine the shape a little bit more. This piece of rod and the vise. So that's the basic forging next to the original one that broke. Now we got to go tap the hole in the mill. I just ground some of this to make it look a little more presentable, and I spot drilled with this spot drill here to get a hole started. And I'm just going to do this manually. I didn't change my X and Y 0 point here. I'll move the machine. Now I'm going to put a drill in there for a 1/2-13 hole, .422 drill. I'm going to drill, just manually jog it and drill that hole, and then tap it manually. We're going to do one of these manual tapping things with the hand wheel. First we got to engage the program, so to speak, here, and just run a tapping cycle, but not give it a G80 to cancel it. We can put it into handle jog. You get some oil on this hole here, on the tap. Now you notice, see, I'm jogging the hand wheel. See how the spindle stays in synchronous with my hand wheel? I don't know if other machines do this, but this machine does. So I can actually, if I increase the jog rate, I get up closer. So put it back down into the slower jog. I can actually tap a hole. See, I'm jogging it in manually. Because that's a spiral point tap, I can just drive it all the way in because it's a through hole. It looks like it's far enough. And then I can jog it out. And if I hit reset, then when I jog, now it's reset the tapping cycle. So here I am zero returning the machine to get ready to start working again after all of that effort to remake this Lathe Dog. I took the part out that I left in the centers and put it on here. And I wanted to be able to, like I said earlier, tighten this thing pretty darn tight because I'm taking about 100,000 step on the radius cuts in this titanium, and you know, if the insert gets dull or something or fails, I don't want that thing to spin in that Lathe Dog on the part and mess up my center that I've machined in the chuck and everything. So I was pulling that almost as hard as I could pull it with that Allen wrench, and everything seemed to be okay. So it seems to be working all right. That's what it looks like on the part. I left the inside as forged. I didn't grind inside of it because I thought the rough surface might actually help it grip the part. So here I'm turning the first part with it on there. I was taking this through the door, the window of the machine's door, so it's kind of not, you know, it's kind of blurry. So that's it on the part.